in this example, we want to use gradient descent to find the minimum of the function f, which is 2x squared plus 2xy plus 2y squared minus 4x minus 6y. And we're going to start at the point 3, 0. So we're going to first of all find the Hessian matrix, which is the second derivative of x, and then x, y, f of y, x, and f of y, y. Now for the second derivative of x, the only part of this that will matter is this one. The first derivative would be 4x, and then it will just go to 4. And for x of y, we have for the first derivative, the only ones that will matter is this one. So we just get 2, and it's going to be the same down here. And for y, we have the same coefficient and y squared, so it's going to be 4 again. This function has eigenvalues 2 and 6, and this means that h is positive definite. Which means it is convex and therefore has a global minimum. So now we're going to find grad of f, and this is just going to be df by dx, which is going to be 4x plus 2y minus 4, and df by dy, which is going to be 2x plus 4y minus 6. And we'll just set that to this. Right. At the minimum of the function, grad of f is going to be equal to 0. So now we're doing gradient descent. And starting at the point x1 is equal to 3, 0, we have x2 is equal to x1 plus alpha, some value, and a search direction. Now we're going to find S1. These are vectors actually, by looking down the gradient, because we need to search towards the minimum at x1 over a value to scale it correctly. And this is going to give us, evaluating the grad of f at x1 gives us 8, 0. So we get x2 is equal to 3, 0, our starting point, plus some alpha of minus 1, 0, because we take a1 to be the modulus of this, which is 8, and then we search down, so we get a minus. And this is going to be 3 minus alpha, 0. Now, in order to find alpha, we need to minimize f along the trajectory. To find alpha, so we have d by d alpha is equal, or of f of x2 is equal to d of d alpha f of 3 minus alpha for x and 0 for y, using what we just found up here and substituting this in the, so then finding the derivative of this. So we have 2 of 3 minus alpha squared, and the y is 0, so we can ignore anything with the y in front, minus 4 of 3 minus alpha. I'm going to set that to 0. And this will give that alpha is equal to 2. So x2 is equal to 3 minus alpha 0, which is equal to 1, 0. And that's the first iteration done.